Hello guys, so today we are going to discuss another important topic in alkyl halides, that is nucleophilic substitution. So we very well know at this stage after doing the board classes that nucleophilic substitution is a very specific reaction to alkyl halides. Alkyl halides undergo nucleophilic substitution. So it will be very important, we need to do that with complete concentration. So why does it undergo nucleophilic substitution? First of all, we have to draw a structure of alkyl halide. So here is the alkyl group and here is the halogen group. Okay? Now halogen is much more electronegative, right, than carbon. So what does this actually mean? This actually means suppose a carbon is there and 3 hydrogen is there. And here is the X. Okay? That is the halogen. So what does this bond means? Bond means electron. And what does electron means? Electrons means cloud of negative charge. Nothing else. Okay. So let us rub this one. So let me ask you, if there is a cloud of negative charge, who is going to pull the cloud of negative charge much more? Carbon or halogen? Obviously halogen. So definitely this cloud of negative charge will be like this. Right? It will be much more towards the halogen. Okay? So at the end of the day, when it happens, definitely the halogen will have some partial negative charge and the carbon will develop partial positive charge. Okay? Suppose there is a nucleophile. What are nucleophiles? Nucleophiles are those who loves positive centers. Okay? Nucleophiles are those who loves positive centers. So definitely this is a nucleophile. So whom it will love? It will tend to attack this carbon, right? Because carbon at this moment is having some positive center. You can also say it is having electrophilic center. Nucleophile will attack the electrophilic center. And what will happen? Carbon, okay? This is going to attach to the nucleophile. And this halogen will leave. इसको हम क्या बोलते हैं? Leaving group. ठीक है, इसको हम बोलते हैं लीविंग ग्रुप. दैट्स व्हाट वी से. नाउ लेट मी आस्क यू वन थिंग. हाउ मेनी हैलाइड्स टाइप वी हैव स्टडीड? वी हैव स्टडीड अबाउट दिस टाइप ऑफ हैलाइड्स, राइट? RI, RBr, RCl and RF. So what do you think? In which case it will be very easy for the halogen atom to leave the carbon. What do you think? See, if it is iodine, the bond length is much higher. I hope you understand what bond length is. Bond length is much higher. अच्छा चलो, bond length, why the bond length is higher? Because iodine as an atom is larger. So if the atom is larger, then the total bond length between the carbon and the halogen will be higher. So definitely here the bond length is higher. So bond length will be, this is higher than this is higher than this is higher than this. This is having very less bond length, RMF, okay? Because fluorine is a very small atom. So best leaving group in this case is obviously iodine. So in case of substitution nucleophilic, this is the best substrate to react or undergo this kind of reaction. So alkyl halides will undergo best substitution nucleophilic type reaction. And generally this fluorides, it doesn't undergo nucleophilic substitution. ठीक है? थोड़ा recapitulate कर दिया, मैंने बोर्ड में भी करा होगा इसको. ठीक है? इतना एक सब ड्रॉप फ्रॉम नहीं किया. But we have also done this in board, right? So what we can say that fluorides, the alkyl fluorides are unreactive to the nucleophilic substitution. ठीक है? तो यहाँ तक कॉपी कर, उसके बाद आते हैं. So you have copied everything. So I will rub it out. Okay. So now we are going to do. There are different types of substitution nucleophilic reaction, namely SN1 and SN2. So first thing we are going to do SN1. Why we are going to do SN1 first? Let's see. 1 से तो चालू होना चाहिए ना, तो यहाँ से लिखता है SN1, that is substitution nucleophilic unimolecular reaction. ठीक है, because this is SN1, because in this case rate is kinetics पढ़ा है ना, rate is equal to rate constant into substrate. So it depends only on the concentration of the substrate. Substrate, what is substrate over here? Substrate is nothing but the alkyl halide itself. So that is why it is called SN1 reaction, because it follows first order kinetics. ठीक है, unimolecular first order kinetics. ठीक है. So how does it react? Let's see. There are two steps here. Two steps. पहला स्टेप का स्टेप नंबर 1. स्टेप नंबर 1 is slow step. Slow step. slow step में क्या होता है? ये जो कार्बो, I will draw some pictures now. This is alkyl halide. This is Weisden dash formula. This is out. Sorry, this is out of the plane of the board, and that is inside the plane of the board. So first of all, we have to do is we have to find out the RS nomenclature for this. That is very important. Okay? RS nomenclature is very important. So how do you find out that? I have already taught you. So if we take say bromine over here, bromine has the highest atomic number. So I will name it as 1. Then this, because this is bulkier group than this is bulkier group than this. So 2, 3, 4. So if you go like this, then it is anti-clockwise. Okay? And if it is anti-clockwise, it will be named as R. Okay? It is R as 1. Okay? R. And the longest chain would be this one. Right? 2 bromo. This one, sorry. Not 2 bromo, it will be 3 bromo. 3. 1, 2, 3 bromo. 1, 2, 3, 4. 3 bromo. Then 3 नंबर पे मिथाइल भी है. So 3 methyl. This is the longest. This is the longest. 1, 2, 3, 4, 5, 6, etc. Okay? This is the longest chain. So this is R type. This is very important. I'll let you know why. I have already given you something on R and S type nomenclature. Please go through that. It's very important in case of alkyl halides. Next is, it first goes slow ionization. Slow ionization means it will form Br minus. So Br minus leaves plus 1 carbocation is going to be. This carbocation will have 3 atoms. This is a 3 degree carbocation. So in carbocation, what is the structure? Can anybody say in carbocation what is the structure? It is sp2 hybridized, right? It is not sp3. It is sp2 hybridized, and it is planar. It is planar. So it will be like this. 3. CH2 CH3. Okay, this is ethyl group, and this one will be CH2 CH2. So this is positive symbol. This is the carbocation. So this carbocation is planar. It is planar carbocation. Now, why this planar word is important? Because in this planar carbocation, you can now come for our next step. Next step is attack of the nucleophile. Now the nucleophile is going to attack this carbocation. So how it will attack this carbocation? From which side? From this side, that side. If it is planar, it can attack from this side also, that side also, right? There is no problem. So इसको रख करते हैं, यहाँ कर लिया. So next is our first step, that is attack of carbocation with nucleophile. So step 2. This is very important. So here is my carbocation. CH3. CH2, CH3. Here is CH2, CH2, CH3. ठीक है? Now what will attack? A nucleophile is going to attack. What kind of nucleophile we are talking about? Let's take OH. OH minus person. ठीक है? OH minus is going to attack at this. ठीक है? So OH minus is generally provided by water molecule. So I will first take one water molecule over here. This one. So this water molecule, or you can take alcohol also. This one. So this water molecule is going to get attack on this one. So this kind of attack we will call it front side attack. What side attack? Front side. Front side attack. ठीक है? So in case of front side attack, it remains as it is. As this donates the electron to the carbocation, oxygen will now have the positive charge. Clear? देखो, oxygen will have the positive charge. ठीक है? Okay, guys. So at this moment, obviously, this is still a cation, and also oxygen having positive charge means oxygen being an electronegative atom, it is having positive charge, which is very unstable, right? We have studied that in resonance. It is very unstable. So in this case, what will happen? Another molecule of OH2 is going to attack. OH2 means water. OH2 means water. So OH2 कहाँ पे अटैक करेगा? देखो, OH2 आपका कहाँ पे अटैक करेगा? ठीक है? वो इम्पोर्टेंट है. OH2 में फिर से आपके पास इलेक्ट्रॉन है. ठीक है? So what will happen? First, this bond is going to give electron to this oxygen to make it stable. So ये bond आपका टूट गया. ठीक है? टूटने के बाद now this electron, because at this moment टूटा सिर्फ नहीं, इसने पूरा इलेक्ट्रॉन ऑक्सीजन को दे दिया. So at this moment it is just H plus. So it needs 2 electrons. So these 2 electrons will be provided by this, and there will be a formation of H3O plus over here, which will get eliminated, and you will get a OH on this side. See, as soon as the OH bond is formed, this bond is going to repel this bond. So this will be shifted like this. CH3, C2H5, okay, and C3H6. So this is the structure now. Now let us see what kind of isomer is it. देखो, oxygen is having the highest atomic weight. I'll name it as 1, 2, 3, 4. ठीक है guys? 1, 2, 3, 4. So previously it was R only, right? Anticlockwise R, and now also it is anticlockwise. So it is R only. You can write the name R3 methyl hexane 3 ol. R3 methyl hexane सी और, ठीक है दोस्त। दिस इज कॉल्ड फ्रंट साइड अटैक। तो इसमें से इस साइड से अटैक किया हो सकता है, नो प्रॉब्लम, बट देयर कैन बी अटैक फ्रॉम दिस साइड आल्सो। This is called backside attack. बैकसाइड अटैक हो सकता है। बैकसाइड अटैक में से क्या होगा, लेट्स सी, ये प्लस आएगा, ठीक है, इसको ऐसे डालो, H ये आ गया आपका प्लस, ठीक है। प्लस इज गोइंग टू चेंज बिकॉज दिस donated the electron to carbon, this will attain the positive charge, and obviously this will remain as it is. Lot of space here, so I'll just show you CH2 CH, okay. Now here it is CH2 CH2 CH, okay. See, this step 2 is fast, this is fast, this is not slow as it was formation of carbon atom, okay. So now you see a very important thing that happened there also. So OH2 means water that comes, and that basically this bond will break, this will donate the electron there, and this will donate the electron to hydrogen, formation of H3O plus, and you will get OH. As soon as OH is going to get formed, it is going to push the bonds like this, so this will be the answer. ठीक है। So in this case again, if you start numbering, so this will have 1, 2, okay, and this one is basically above the plane of paper, so this will be 3, this will be 4. So 1, 2, ठीक है, 1, 2, this is clockwise, ठीक है, clockwise 1, 2, 3, 4. So basically you are going anti-clockwise, ठीक है, because this is above the plane of paper, so it is not like that you have to go like this, you can go like this also, ठीक है, 1, 2, 3, 4, and it will have S configuration. What configuration? S configuration, ठीक है. So here what is happening, an R isomer, this was an R isomer, the halide is going to form a S configuration. R configuration changes to S configuration. So in this case, in case of backside attack, we are getting S configuration. ठीक है. In case of backside attack, we are getting S configuration. So while we are getting S configuration, that means here inversion is taking place, and in this case retention was taking place. Also it means that we are getting equal mixture of R and S configuration, 50%. That means at the end of the day the mixture will be racemic mixture, ठीक है. Hope you understood this. Little complicated, but it is okay, it's understandable. Only this part maybe you are having some problem in this part. See, this part you can draw this way also, because see, this is out of the plane of the paper, so not necessarily this OH is going to push this, because this is here, okay. This OH may push this on this side also, so it can happen like this also, right? Why should I write that like that? I should write it like this. Push तो किया, ऐसे पुश कर, इस ऐसे है, उसको ऐसे कर दिया. किस साइड में? इस साइड ही गया ना. 1, 2, 3, 2, 8, 5, 3, 4. ठीक है, हो गया. इस कॉन्फ़िगरेशन क्लियर, ठीक है. So this is how you need to do this kind of things, ठीक है. एंटी क्लॉकवाइज, क्लॉकवाइज में R, एंटी क्लॉकवाइज में S, ठीक है. And it is very important because sometimes nowadays we are seeing that these things are also becoming important even in the exams. So definitely you need to go through this. Now this ends the SN1 type. You also have to do SN2. 1 के बाद 2 आता है. And after that we have to do some exercises also. Because in organic chemistry, if you don't practice exercises, you don't get confidence. Okay? So let's wait for some time. Hello guys. So SN1 तो खत्म हो गया. अभी SN2 भी करना है. So we have to do SN2 right now. What does SN2 means? Substitution nucleophilic bimolecule. Why it is bimolecular? The reason is this. The rate equation can be written as rate constant substrate that is alkyl halide over here and also the nucleophile. This is very important. So the total rate of this reaction depends on alkyl halide ka nature or nucleophile ka bhi nature. So in this case it's a one-step reaction. It's a one-step reaction. How? The nucleophile comes, it's an alkyl halide, it forms an transition state like this, X, this is called transition 1, and then it gives product that is RNA plus X minus is the living group. So in this case also, Ri will have more reactivity than Rr, more than RCl. RF is almost unreactive. ठीक है? समझ में आ रहा है? Okay. But what most important thing is that here no carbocation is formed. No carbocation is formed. If there is no carbocation, there is definitely no planarity. Due to the planar structure we have seen in SN1, the attack could have happened from front side and the attack could have also happened from the back side. But at this moment, there is no planarity. So only back side attack is possible in this case. So I will show you. H3 over here, this one C2H4. So this will attack from back side. Okay? There is no planarity, so it will attack from back side. This is written in some of the books that there is no planarity, it will attack from back side. What I didn't find is that why it will attack from back side and not attack from front side. See, this is a nucleophile, a negatively charged species. This is also an electronegative atom attached to carbon. So when it comes from this side, this will not let it form this transition state. Okay? So it is not possible for it to come from the front side, it has to come from the back side. Common sense, logic. Okay? So only back side attack is possible. So in this case, what is going to form? It is going to form C, this is OH, back side attack is X. Like this, पूरा बॉन्ड हमने बना ली. A little bit shift happens like this. This is H. This is CH3 and this is CH2 CH3. Okay? So this is going to happen. And at the end of the day, I said you, this is basically out of the plane of paper. तो इसको जब OH push करेगा तो ये इधर नहीं, इधर जाएगा, ठीक है? X के तरफ जाएगा. So now obviously X leaves, right? X leaves. This breaks up. X leaves. OH forms this bond. complete bond, and starts pushing this bonds towards that side. It's like an umbrella over here. If you see this one, this was an umbrella like this. You give some wind and the umbrella goes like this. Right? And so what happens is, this part of the umbrella, which was basically on this side, the wind comes and it goes like this. It forms like this. Okay? And definitely this will be below the plane of paper, CH2, CH3. Okay? So, if this is bromine, say, so obviously it was 1, 2, 3, 4 according to atomic number. So it was clockwise. So it was a R configuration. If you see this right now, then it is 1, 2, 3, 4. It is anti-clockwise, it is an S configuration. We have previously also seen that in case of backside attack, we will get S configuration, right? That there will be inversion. So in this case, only backside attack is taking place. So inversion has to take place. There is no chance of retention, and hence in case of SN2 reaction, there will be inversion of the molecule. Okay, very important. You can write 2-3 things that is important over here. That is, in case of SN1 and SN2, there is some differences, and which we are going to discuss right now in case of SN1 and SN2. So, it's important. So, I hope SN1 and SN2 mechanism wise it is clear. In case of SN1, racemic mixture is formed. In case of SN2, no racemic mixture, only the configuration it inverts, okay, inversion takes place. I have also given you something on inversion and retention. You should go through that also, so that you can get a fair amount of idea what is going on in this reaction, and you can understand why those things are given to make it easy for you. So let's go for an comparison. SN1, right there, SN2. Okay. So in case of SN1 or SN2, the common point is Ri more than RBr more than RC. RF is unreactive in both the cases. Okay. So this reactivity order doesn't change. Okay, it doesn't change. Next is, what about the type of halides? In case of SN1, 3 degree will be more than 2 degree, more than 1 degree. Why? Because if you see, in case of SN1, there is a carbocation formed, and obviously 3 degree, and the total reaction depends on the stability of the carbocation, because there is a carbocation formed, and that is very important, and that is the slowest step. On that step, the total reaction depends. So carbocation has to be stable. So obviously 3 degree carbocation is more stable than 2 degree, more stable than 1 degree. So SN1 में ये reactivity order है. SN2 में there is no carbocation form. So whenever there is 3 degree, there will be chances of SN1 and not SN2. So definitely in case of SN2, 1 degree will be favorable like this, 3 degree, okay, more than neo type. Okay. So this is also important. Next is solvent. See, in case of polar or protic solvent, polar or protic solvent मतलब H2O or CH3OH, say an alcohol. These are protic or polar solvent. These have some charge separation. If this kind of solvent is given, then SN1 will be favored. So SN1 favored by polar or protic solvent, means water, alcohol and all those things. Okay? SN1 will be favored. Okay? Next point is, okay, concentration and nature of nucleophile. See, in case of SN1, you know it very well that rate is equal to K substrate, right? In case of SN2, rate is equal to K substrate and nucleophile. So definitely in case of SN1, it won't depend on nature or concentration of nucleophile. In case of SN2, it will be. So please write it down. In case of SN1, there is no dependence on nature or concentration of nucleophile. In case of SN2, it depends. Okay. There are certain species like vinyl, aryl halides, vinyl and aryl halides, or breached bicyclo compounds. Please go through my breached bicyclo compound video, is there. So breached bicyclo compound, okay, when halogen is attached to breached carbon atom, it is attached to breached carbon. Okay. In this case, definitely there won't be any reactivity towards SN1 and SN2. Okay. Remember, SN1 and SN2 is not for vinyl halides, it's not for aryl halides, it's not for breached bicyclo compounds with halogen attached to the breached carbon atom. Okay. So this is very important. Please remember this one. Okay. Because in case of SN1 or SN2, we need there are two kinds of reaction. One is formation of carbocation. In case of SN1, which is not possible over here, carbocations are not stable. And in second case, there is a requirement of formation of transition state, which is also not possible in this case of species. In case of 2 degree, 1 degree allylic and benzylic, please write it down. In case of 2 degree, 1 degree allylic and benzylic. Benzylic मतलब ये वाला. This benzylic allyl, ठीक है? Allylic I think you know, and 2 degree also. So these are in between 1 degree and 2 degree. देखो 3 degree दे देगा ना तुम बोल देगा SN1, 1 degree दे देगा तो तुम बोल देगा SN2 में. लेकिन ये बीच का जब देता है ना तो प्रॉब्लम हो जाती है, ठीक है. जैसे 2 डिग्री, 1 डिग्री allylic, then your other one I said benzylic. In this case it will depend on solvent, कौन सा solvent दे रहा है उसके ऊपर डिपेंड करेगा, and also the nucleophile. If the nucleophile is strong enough, it will undergo the reaction, that is either SN1 or SN2, ठीक है. कुछ भी कर सकता है, but it will depend on the nucleophile and also the solvent. Definitely when it depends on nucleophile, when the reaction depends on nucleophile, this kind of wherever there is dependence on nucleophile, like benzylic, in benzylic there is dependence on nucleophile. If some reaction is dependent on nucleophile, suppose it is said that this radical is reacting with this and this reaction depends on nucleophile, that means it is undergoing SN2 reaction, right? SN2 में आता है, SN1 में कोई चांस नहीं होता, ठीक है. So that things you need to know, ठीक है. And in some cases you also have to see the carbocation stability. So if you see the benzylic carbocation stability and the allylic carbocation stability, they are much more stable than 2 degree. Allylic and benzylic are much more stable because they have resonance stability attributed to also along with normal class I stability that you got in 3 degree. So definitely benzylic and allylic will have higher chances for doing SN1 reaction. ठीक है? So these are important things that I said you and will be important for we solve problems, and we are going to solve problems right now. Okay? So let's rub this. I have chosen some problems for you. Basically I have written this so that you get a fair amount of idea the kind of questions that can be expected from you. Let me go for first easy ones. you have to identify which of them gives faster SN2 reaction. So number A is given. Number B, but any one of them, either this or this. Okay. Sure. Let's identify which goes faster SN2 reaction. So for SN2 it is very clear to us that 1 degree will have better SN2 reaction. तो first one देखो तो halide है 1 degree तो ये correct है. Second one में दोनों ही 1 degree है but iodides are better towards substitution nucleophilic. It's a better leaving group, so this will have faster reaction. So third one is this one. If you see this one, this is a little bit tricky, but as you can see, you have to understand which will give you faster SN what reaction? SN2 reaction. That means see, if you consider this one, this is basically 2 degree है ना, 2 degree, and if you consider this one, this is also basically 2 degree, but इसमें जो bulky group है, ठीक है, that is attached with this one. So definitely ये जो bulky group है, this will try to take away the reaction towards elimination reaction. बोर्ड में पढ़ाया था, जितना bulky group आएगा, इसका कार्बन के साथ जो कार्बन कनेक्टेड है, that is itself bulky. So इस केस में आपका elimination reaction का chances बढ़ जाता है. So in that case, this will be the faster reaction. Next is this one. Obviously, this one will have faster reaction. This is 2 degree, no chance. Next is this one. This is 2 degree. This is 1 degree. This will have faster reaction. Very easy. Faster SN1, faster SN2. Next we'll go for faster SN1. Okay. जल्दी जल्दी होना है. So faster SN1 reaction we are going to do now right now. ठीक है guys, so now we are going to check out which has faster SN1 reaction. So let us see this one. So SN1 के लिए जितना भी डिग्री ज्यादा होगा उतना अच्छा SN1. So this is 3 degree, this will go faster. This is 2 degree, this will go faster. This is 2 degree, will go faster. This is 3 degree, will go faster. In this case, you need to same. Both are 2 degree. But this is allyl carbocation formation का chances है ना, double bond उसके बाद plus आएगा, so there will be resonance. So this will have much more stable carbocation stability. So obviously this will have faster SN1 reaction. It's a nice question. We'll do another very nice question right now. Okay, 2-3 nice questions are there. to solve problems, it is clear that you are going to in this reaction, this is also given as 1 mole, this is also given as 1 mole. So what is the product that has been asked? This is a nucleophile. Only 1 mole is given. So this nucleophile can attack only one of the centers, either this one or that one. Which one it will attack? Come on guys. Which is a better leading group? Iodide. Obviously iodide will attack, right? See. Okay? Clear? Next is another very important question over here. NH2. इसके बाद आपका 4 1 2 3 4 5 इसमें हिंट दे दिया और लिख दिया कि SN2 होगा, which is already given to you. So in this case, there is no SN1, it's only SN2. It has been said to you, so SN2 reaction. So you have to go by SN2. So carbocation लेके सोचना ही नहीं. So in this case, there is no nucleophile, but any amine group has some electrons, right? Huh? So can't it form this kind of compound? ठीक है, देखो CH2, 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 CH2 and यहाँ से Br हट गया, ठीक है, यहाँ से एक हाइड्रोजन चला गया उस Br को लेके, तो इधर पे जो बचा है can't that be reacted like this? Why can't it be? This has electrons, man. Substitution nucleophilic, simple. This is the answer. Okay. So this is basically SNI type reaction. We have discussed somewhere earlier. SNI type, that is basically substitution nucleophilic intramolecular. Okay. Intramolecular, not intermolecular. Okay. So that's it about SN1 and SN2 today. We will obviously go through E1 and E2 also, and there will be some competition reaction between E1 and E2. See, these topics are very important with respect to alkyl anions. If you assess the question papers given in JEE Mains, JEE Advanced, they don't go for a single एक ऐसा अजीब किस्म का रिएक्शन दे दिया, कभी देखा नहीं ऐसा कुछ देता नहीं है. They give you known things that is already there in NCERT, but they give you tough questions on it. They give you intelligent questions. They check your application skill on those reaction mechanisms which are given in NCERT. तो NCERT में जो रिएक्शन है उसका आपको एकदम खोल के खींच के खाना है, बस हो जाएगा. ठीक है? Okay guys, thank you. We'll come back with E1 and E2 and also competition between E1 and E2 and SN1 and SN2.